Hi grade 11s, this is the Opinionated Science Educator. Welcome to this pre-lesson video tutorial to help you engage with the pre-lesson activities. Today's topic is on electrical circuits. So the video tutorials are a revision on how to do the calculations you learned in grade 10 because you will be applying these concepts to electricity in the home. Hopefully by now you've gone onto ClickUp and you've done the pre-diagnostic test. These questions will give us a good indication of how much you know about electricity and can help us, the science teachers who are teaching you, develop additional support materials. So if you haven't yet done the diagnostic test, please pause this video now and go back and complete the diagnostic test. This is the pre-lesson activity and it is a video tutorial. In this video tutorial, you need to be able to ensure that by the end of the tutorial and by the end of watching the videos, you are able to determine the total resistance in a circuit, apply concepts related to current and voltage across resistors connected in series and parallel, use Ohm's law to calculate either voltage across or current through resistors placed in series and parallel. In the context session, you will be applying these concepts to electricity in the home. So, you need to watch the following two videos. The first is from Derek Owens on YouTube, and it deals with series and parallel circuits. The second is the Organic Chemistry Tutor, and it deals with the use of Ohm's law. While you watch these two videos, please make sure you try and answer the following questions. And you need to consider the following. What is the difference between a parallel and a series circuit? Why is a series circuit considered a potential divider or a voltage divider and a parallel circuit considered a current divider? What happens to the total resistance when resistors are connected in parallel? What happens to the total resistance when the resistors are connected in series? And what happens to the current as resistance increases or decreases? And obviously, you need to be able to use Ohm's law in calculations. The first video covers a comparison between both a series and a parallel circuit in terms of what happens to the resistance and the current. And you should be able to see the link now coming across the screen. So this is a good time to pause the video and pause this video and watch the first video tutorial. So grade 11s, welcome back. I hope you found that video useful in giving you a better understanding of the difference between a series and parallel circuit. The second video by the Organic Chemistry Tutor also looks at series and parallel circuits, but the difference is that he uses Ohm's law to calculate resistance and current in the circuits. There is also brief mention about electrical power in the circuit, so don't worry about that too much because that will be covered in more detail in next week's contact session. The link for the video should be appearing across the screen now. And just a reminder, the links to the videos are actually on this week's session tab on ClickUp. So you can get the videos there if you were unable to see the links here on this video. So pause the video now and go and watch the YouTube video. And remember to try and answer the questions I posed earlier on while you watch the video. So grade 11s, I hope you found that video from the Organic Chemistry Tutor useful in helping you use Ohm's law in calculating various aspects, either the resistance or the current in both series and parallel branches. You will be applying these concepts and these ideas and the calculations in the contact session where we'll be looking at electricity in the home. So I thought maybe before you go, I've included a question here for you to do from one of the matric examinations, and it just gives you additional practice calculating total resistance and aspects of current and so on using Ohm's law. The question will appear on the screen now. So here is the question. There is a circuit with a series parallel combination. The resistances are given to you and the total voltage or the EMF of the battery is also given to you. You are to calculate the magnitude of the current. Now, obviously, before you can do that, if you look at the mark allocation, you have to do two calculations to get 6 marks. So, in order to calculate current, you need voltage and the resistance. So you need to work out the total resistance in the circuit first. For the second part, you have to calculate the potential difference across the 15 ohm resistor. Now, if you look at the mark allocation, it is clear that this is not a long calculation. It's a single calculation. You need to apply what you know about current in a parallel circuit.